All right, we're going to talk a little bit about Gram staining here. Gram staining was discovered or figured out, not discovered, it was figured out in the 1880s by Hans Christian Gram. And he realized that there were two different kinds of bacteria based on their outer cell walls, cell membrane kind of structures that would stain differently with different techniques, or the same technique but different results. So we'll start with gram positive. So you'll notice the gram positive, here's your cell membrane, here's just a protein in the cell membrane. Outside of the cell membrane is this really thick peptidoglycan cell wall. Peptido tells us it's got amino acids, protein. Glycan tells us it's a sugar. So it's made of proteins and sugars. And it is what happens first. The first thing we add is crystal violet. So we put crystal violet, which is violet, purple in color. And this is going to bind to this peptidoglycan. Then we add iodine. Iodine makes the crystal violet stick to the peptidoglycan even more. We do the same thing to the gram negative. We add crystal violet, we add iodine, but I'll talk about that in just a second. Okay, so we've added the crystal violet, it's sticking to the peptidoglycan, making it purple. We add the iodine, it forms this large iodine crystal violet complex that binds to the peptidoglycan even more, so it really kind of locks that crystal violet in. We add alcohol as a decolorizer. It's really more important for the gram negative, but it is going to impact the gram positive by dehydrating it and closing some pores in the cell wall, making it harder for the crystal violet to get out. So it helps to lock in that crystal violet. However, if you leave the alcohol on for too long, it will actually dissolve all of that, and the crystal violet will leave. So you have to be careful not to leave the alcohol on too long. And then the fourth step is you add the safranin, which is the pink dye. It actually binds to the cell membrane, and it will bind in gram positive, but because the crystal violet is there and it's so dark, you don't see that pink dye. So these are going to show up as purple. Gram negative, notice they have a cell membrane with the proteins, they have a thin peptidoglycan layer, and then they have basically another cell membrane out here. We call this the LPS, or the lipopolysaccharide layer. Because it's got lipids and it's got polysaccharides, these carbohydrate chains out here. And so what happens is when you add the crystal violet to this, it can't really get to the peptidoglycan. Maybe a little bit does, but not much of it. It's kind of blocked by this LPS. The iodine binds to the crystal violet, but again, that just makes it even bigger, and it can't really get through to the peptidoglycan. Then we add the alcohol. The alcohol is going to break up this lipid layer and wash it away, along with all of the crystal violet and iodine that's still kind of hanging out up here. And so now we're just left with this peptidoglycan layer and the original cell membrane. And when we add that safranin, it's going to come in and bind to the cell membrane. So the alcohol washed away all the purple, the safranin is pink, and so what we're left with is this pink dye. So again, gram positive, lots of purple dye up here, pink down here, but you can't see it. It's kind of blocked, I guess you could say, by the purple dye. Over here, the purple washes away, and you're left with just the pink down here. And so when you look at them, your positives are purple, and you can remember that because positive starts with P, and purple has a P in the middle, and your negatives are pink, and you can remember that because negative has an N, and pink has an N in the middle. And so here are your positives and some negatives. And I hope that helps. That's how you do gram staining, why we do it, to differentiate, and the importance is it allows us to differentiate between bacteria so that when we're treating an infection, we can say, okay, we know this is gram negative, let's shoot it with these antibiotics, or we know it's gram positive. There are broad spectrum antibiotics. I think penicillin is one that will kill both. So if they aren't sure, or if you don't have time to test, then a lot of times they'll give a broad spectrum antibiotic. But if they have time and they know, you can use a more specific antibiotic that will be more impactful. So that is why we do gram staining, how we do it, the importance of it, and I hope that helps. If you have any further questions, just let me know, and we can go over those.